Here we are in Chapter 5, Review Exercises with the solutions to numbers 35 through 40. Now, these are all to solve for the variable by factoring, which means, first of all, we've got to get it equal to 0. That's the first step. Second step, that's when we use our factoring. Now, factoring could be in any number of ways. It could be the difference of squares, pulling out the greatest common factor, 3-term or 4-term. So we're going to remind ourselves of that as well. And then each factor gets put equal to 0. These are the steps. Each factor equals 0, or each piece. There we go. All right, so let's do it starting with number 35. So first get it equal to 0, so add 20 to both sides. And then let's write this down. We get x squared minus 13x. That's plus 42 equals 0. Check. Step number 1 is good. Now we've got to factor this. We have a trinomial. Well, we first look to see if we have a greatest common factor, and we do not. So we now have what multiplies to a 42. Could be a 1 and a 42, or a 2 and a 21, or a 3 and a 14, or a 6 and a 7. Looks like 6 and 7, negative on each of those, will give us x minus 6, x minus 7 equals 0. So that gives us, yeah, we're factored. Good. So now each factor equals 0. So x minus 6 equals 0 will give us x equals 6. There's one answer. And x minus 7 equals 0 will give us x equals 7. So we have two answers, x equals 6 and x equals 7, and that corresponds to the degree of the polynomial, that we have two answers. All right, number 36. Get it equal to 0. Check. Factor it. Ooh, negative 6. This is trinomial with a leading coefficient that is not equal to 1. This one had a coefficient equal to 1. So this guy, we're going to take negative 6 times 10 is a negative 60. And that's going to be 1 and 60, or 2 and 30, or 4 and 15, or 5 and 12, or 6 and 10. Whew. This is negative, so they've got to be opposite signs. So they're going to subtract to a negative 11. We're going to use the negative 15 and a positive 4. So let's break it up. Negative 6x squared plus 4x minus 15x plus 10 equals 0. We now have 4 terms, so we use grouping. Chop that guy in half. We pull out a negative 2x, and we're left with 3x plus 2. And then on this one, we pull out a negative 5, pulling out this leading sign. The sign on the leading coefficient allows it to, when we do it, these two will match up as 3x plus 2. So pull out the 3x plus 2, and we are left with negative 2x plus 5. And now remember, that was just the factoring part. We're not done yet. This is now equal to 0. So now we have two equations to work with. We get negative 2x plus 5 equals 0. So this is, we're setting each factor equal to 0 and solving it. So we get negative 2x equals a negative 5. And then divide by a negative 2, x equals a positive 5 halves. And the other one, 3x plus 2 equals 0. 3x plus 2 equals 0. Subtract 2, we get 3x equals a negative 2. Divide by 3, and we get x equals a negative 2 thirds. Excellent. Those are the two answers for number 36. And notice that matches the degree of the polynomial, two answers. All right, now we have number 37. So we got to get it equal to 0. So we got to subtract 5x over here. Writing that out, we get negative 5x cubed minus 10x squared minus 5x equals 0. Yay, we got it equal to 0. We are set and ready to go. Now we got to factor. Looks like a negative 5x could come out of all of them. And we're left with x squared minus 2x, no, plus 2x plus 1 equals 0. Okay, so far so good. But we have to look harder now. We now have a trinomial, leading coefficient 1. And so multiplying to 1, it's a 1 and a 1. They add to 2. Good. Yes, this is x plus 1. X plus 1. You may have also recognized the pattern of a perfect square trinomial. This is x squared plus 2 times 1 times x plus 1 squared there. That would have been all right to recognize. All right, so we factored it. Now each factor equals 0. We get negative 5x equals 0. Solve it and we get x equals a 0. Yeah, notice when we have a variable out here as a greatest common factor, we actually get an answer, 0. That's important to note. Okay, then x plus 1 equals 0. That's x equals a negative 1. And then that gives us the same thing. So negative 1 happens twice, but we have two answers, 0 and negative 1. But it happens twice, so that's where we get our 3 to match the degree of our polynomial. Number 38. Already equal to 0? Check. Now we're going to factor it. Okay, is there a common factor among everything? 4 looks like it's good. Oh, nope, there's no 4 in that third term. All right, so 4 terms. Cut it in half. Pull a 4x squared out of the front. We get x plus 4. And out of this back one, we can pull a negative 1, and we get x plus 4. That's good. Pull out that x plus 4, and we get 4x minus 1, timesing that 4x squared minus 1, timesing that x plus 4. Good. Now let's look harder. Can any of these go down further? Yes! That first factor is actually a difference. There's a subtraction right there, difference of two perfect squares. And we know that pattern. That's a 2x plus 1, 2x minus 1. And then we have the x plus 4 that is already as low as it can go. Okay, so now we've factored it. So now we have 3 factors to set equal to 0. We get 2x plus 1 equals 0. Subtract 1, you get 2x equals a minus 1. X equals a negative 1 half. Good. Next one, 2x minus 1 equals 0. Set that factor equal to 0. 2x equals 1. Divide by 2 and we get x equals 1 half. And then the next one, x plus 4 equals 0. Subtract 4 and we get x equals a negative 4. So we get 1, 2, 3 answers. I'll write them up here. X can be a negative 1 half, a positive 1 half, or a negative 4. There we go. Wow, 3 answers, and notice that corresponds to the degree of the polynomial. Great. Number 39. Oh, yuck. Okay, we got to get it equal to 0. So we can pull this one over here if we want. Ooh, but we could add the x squared over. And then the x squared's positive, and then we could subtract the 100. Oh, what do we get? So 0 equals positive x squared minus 121. Oh, I like that. I like that. Because now look, this is 2 terms, which means we're looking for a difference. There it is, subtraction of a perfect square, and then 121. This is 11 squared. So this gives us x plus 11. X minus 11 as our factors. Now on to step 3. Each factor must equal 0. X plus 11 equals 0 gives us x equals a negative 11. There's one of the answers. And then x minus 11 equals 0 gives us the other answer of x equals 11. Great. Okay, and the last one. Number 40. Ooh, this is big. Step number 1, get it equal to 0. So subtract this 25 from both sides. So we now have 4x cubed plus 4x squared minus 25x minus 25 equals 0. Now let's factor it. Pull out the greatest common factor. X, nope, that 25 doesn't have an x in it. 4s and 25s, nope, no greatest common factor, but 1, 2, 3, 4 terms. So cut that guy in half. Pull out a 4x squared, and we have x plus 1. Pull out a negative 25, and we're left with x plus 1. So that gives us 4x squared minus 25 x plus 1. Now let's look harder. Can either one of these go down further? Yes, this is two terms. That's a difference of perfect squares. 4x squared is 2x times 2x. 25 is 5 times 5, so that breaks down further into 2x plus 5, 2x minus 5, and then this one, x plus 1 equals 0. Good. Now, step number 3. Now that we got it factored, we take the first one, 2x plus 5 equals 0. That gives us 2x equals negative 5. Divided by 2, x equals a negative 5 halves. Now we take the second factor, that's 2x minus 5, and set it equal to 0. 2x equals a positive 5. Divided by 2, x equals positive 5 halves. And then we take this third factor, this x plus 1, and set it equal to 0. And we get x equals a negative 1. All right, so there are our 3 answers for number 40, and indeed it matches the degree of the polynomial. Excellent.